What's up guys, L's Math Tutorials here, back for another trigonometry video. Today we're going to be learning about the general sine function and its components and how to find the 5 points. Now these two are essential concepts throughout high school trigonometry. Now you will need to know this very well and be able to produce these 5 points very quickly to be able to properly graph your functions, your general sine functions. Now, let me go over the components of the general sine function for you. The general sine function's general function is y equals a times sine of b times, in parentheses, x minus c, close parentheses, plus d. As you can see on my slide right here. So the A is amplitude. This amplitude affects the size of the waves in your sine function, because your sine function is made up of what I call waves. The amplitude on its own will always be positive. However, there can be another modifier added at the beginning of this function, which is a negative sign, which would result in a reflection. Next, the period. The period is 2 pi divided by b if b is superior to 0, right? So that means the default period is 2 pi because your default b is going to be 1. However, if there is any value in the b position, you will divide 2 pi by that value. Now, the principal axis is y equals d. That means the default d, which is 0, would place the primary axis of your function on the positive x-axis. However, if there's any value on d, that will move your central primary axis for your function and take it off of one of the main axes. Now, to give some context on the function itself, y equals a sine of b times x minus c plus d is obtained from y equals sine x by a vertical stretch with scale factor a and a horizontal stretch with scale factor 1 divided by b, followed by, as I didn't mention earlier, a horizontal translation of c units. The c value here is how the horizontal translation, that means you'll move it towards the right if c is positive and the left if c is negative. Now here I'm going to show you an example of a general sine graph. Now this example I'm showing you is going to be from negative pi to positive pi. In your books, you will likely see a lot of questions where the 0 to 2 pi is used as a default. However, for this, I will be using negative pi to pi because I find that in general, in math, this appears more in your later years of mathematical education. Now, here you might not understand at all any of what this graph means. However, the tables on top here, you'll see this graph, you'll see, oh yes, it's a sine function, but you might not understand at all what I'm trying to say with the tables on here. Now, I'm going to explain it to you. So the first row is the value of b times x minus c. Now, you might not see how this is relevant yet, however, soon you will. So the value of b times x minus c for your 5 points. These 5 points are the 5 essential points you will be using to trace your graph. You will place these 5 points on your graph and you will trace the curved lines between them. So now these points, the b times x minus c will be equal to negative pi divided by 2, 0, pi divided by 2, and pi. Now you won't be using these values on their own. You have to factor in the a and sine, which if you factor in those two, the values would be 0, negative a, 0, a, and 0. And now you find the raw x value, which would be c minus pi divided by b, c minus pi divided by 2b, c plus pi divided by 2b, c plus pi divided by b. Now finally, you combine these values together to find the y equals of these different 5 points, which would be d, d minus a, d, d plus a, and d. In the end, you will be using the values you found in the third row and in the fourth row to graph your points. Now, I will give you an example using my second graph here, my second table here, using the actual numerical values of this general sine function. Now, the entire function is y equals 1 divided by 3 sine of 2 times x minus pi divided by 3 minus 1.5. Now, in this case, the b times x minus c would be 2 times x minus pi divided by 3, which would give you minus pi divided by 2, 0, pi divided by 2, and pi. Same values as you would have had normally. Now, 1 divided by 3 sine of 2 times x minus 3 would be equal to 0. Negative 1 divided by 3, 0 once more. Positive 1 divided by 3, and 0. You might be noticing a pattern, and yes, you're correct. The next value here would be negative 1 divided by 3, followed by 0, followed by positive 1 divided by 3, followed by 0, followed by negative 1 divided by 3, and so on, so forth. This is the most consistent value here. Now, next you will have the x value, which would be pi divided by 3 minus pi divided by 2 equals negative pi divided by 6. And next you'll have pi divided by 12, pi divided by 3, 7 pi divided by 12, and 5 pi divided by 6. Now, once more, you will be having a relatively consistent value here, the y value. You will start with negative 1.5 because you're factoring in everything you have calculated above. The entire 1 divided by 3 sine of 2 times x minus 3 pi divided by 3 minus 1.5 is factored into here. Now, the first value would be negative 1.5. The second value would be negative 1.833. The third value would be negative 1.5 once again. The fourth value would be negative 1.167. And the final value would be negative 1.5 for your 5 points. Much like the value of 1 divided by 3 sine of 2 times x minus pi divided by 3, this is also a constant repetition of a pattern. You'll see minus 1.5, and then minus 1.833, minus 1.5, minus 1.167, minus 1.5, minus 1.833, minus 1.5, minus 1.167, and so on so forth as an infinite pattern. Now, we'll be moving on to another example. This example, there is very little different in this example than the other example. It's simply different numbers and different table with a different 5 points. However, I already explained how the 5 points work. Of course, you use the first two values. You find the first two values. However, you cannot trace your graph with those first two values alone. In the table, you find your x and y values using the values you calculated above to be able to trace your 5 points and draw your graph. Now, I'll give you a few seconds to pause and screenshot this graph and the table if you want to look at it further. And that is all I'm going to be going over today. Thank you very much for listening.